So now that we have a little bit of context in place for our FormIt model, it's time to go ahead and do some analysis work on what we think the design is going to do and how we think it's going to perform. So there are two primary areas where we're going to look at energy analysis. The first has to do with lighting and sunlight, both in terms of visual analysis, understanding how shade and shadowing is going to work, and then also how much let's see here, what the actual intensity in terms of British thermal units are going to be on a surface. Again, having to do with solar energy and sunlight. And then the next one is just in terms of overall energy use by the building, running an overall annual simulation using a tool in FormIt called an insight, or generating an insight. So we're going to dive first into sort of a visual analysis with shade and shadow. So again, we already have our latitude and longitude set by establishing our location of our site. And underneath this panel is sun and shadow. So we're going to activate that. And we're going to turn on shadows. And immediately we get some feedback in terms of what shade and shadow is going to do overall on the building performance. So let's turn on this panel once again, and you'll notice we can establish. So right now I have this set for the winter solstice. This is where the sun is going to be the lowest in the sky, and I can set my time of day, and obviously we have a longer shadow pattern. So if I had the context modeled, across the street here on the just south of the site, we might be able to see at what point we would have shadows from adjacent properties impacting the southern exposure. And at the same time, we can switch this to the summer solstice, June 20th. And we can see obviously a little bit higher intensity in terms of the sun, and then we can see the shorter shadow pattern, and again observe anything that might be happening in terms of the exposure, shade, and shadow on our project, as well as if I have some overhangs. Like let's imagine if we had something along this edge right here that might act as a shading device. I can begin to study exactly where I needed to position that shading device to get us the right kind of solar screening, or the right kind of solar shading. Let's say again for that June, July months, and sort of begin to understand how I could keep glazing or openings in the shade throughout certain times of the year. So the next part of this also has to do with solar radiation. So let's look at the solar analysis button. And again, you need to be logged in to the full Fusion 360 to see this tool set. But this is going to allow us to look at a month in terms of understanding BTUs on a surface, or if I switch from monthly peak to year cumulative, so I can see the best position and best location to put solar panels, things like that. So in this particular site, I might be really interested in August as a time of year where the temperatures are really high, the outdoor temperatures are really high. And this would give me an idea of which surfaces are going to be very intense in terms of British thermal units. So let's go ahead to run this. I need to either select a surface, or I can select all the surfaces. I'll double click to select all the surfaces for a building, and we're going to run the Analyze tab. It's going to take just a few seconds to cook the data. So again, a British thermal unit is the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. And to give you an idea of what that is, a 100-watt light bulb is somewhere in the neighborhood of 340 BTUs, I believe. So if we look at this as a surface here on the roof, now that the calculation is done. So this is in August. We're already, pushing the high 90s on a regular basis in this particular site. And we have the heat equivalent of about one light bulb, one 100-watt light bulb, which is enough to burn your hands, every square foot across the surface of this roof. So we have pretty high intensity in terms of BTUs that we need to block in terms of how what kind of material we are using to reflect that solar radiation back up, in terms of the quality of that roofing system, and also that we're trying to block from coming into the building. So again, you can see even having this little shading device makes a pretty massive difference in terms of that heat energy transfer going into the building. So again, all of those things to think about. If I change this at any point to your cumulative, I get immediate updates, as this is already cooked the surfaces in terms of BTUs or kilowatts per square foot in this case, across everything for the year. So I can set this back to month, and I can observe any month on the surfaces as well. So let's go ahead and accept those values. And again, if I want to get these values out of the system, again, the fastest way to probably do this is to just go ahead and hit print screen on your keyboard and paste that directly into Photoshop. And I can capture my graph right here that gives me the visual feedback in terms of how many BTUs per square foot that I have. So let's go ahead and close that, and let's do our energy simulation next. So the energy simulation tab is right here, this 19.1 button. And first thing you'll notice, if I select that and go to Generate Insight, I'm going to see this note, at least one visible object with levels applied is required to run energy analysis. So the first thing that I need to do is take the massing for the project that I'm looking at right here, and I need to establish a set of levels on the interior. And levels are simply going to give me square footage on the inside that the energy simulation can run against. So let's go ahead and select all of this massing object right here. So again, I'm going to double click, and I'm going to turn on use levels. So right now, it's done a base analysis on it and said, okay, we can do 3 levels. This is about, I believe this is a shave over 30 feet tall when I modeled it. So you can see it's saying, I think I can squeeze in 3 levels, one at 1 or at 0. So on the site, 12 feet and 24 feet. Well, I know this is only a 2-level project, at least in my early conceptual thinking. So I'm going to turn off level 3, and you can see that line disappears. And let's just, for the sake of being averages, let's go ahead and raise this level from 12 feet to 15 feet. So I'm going to go to the Levels tab, and I'm going to edit level 2 to be 15 feet. You can see that blue line move up a bit. We're going to go back to the Properties panel. And for the sake of running this insight, let's go ahead and let's delete this surface right here. Because that was fairly arbitrary when I placed it in. And so I need to fill this panel back in, so I'm just going to use my line tool, trace one edge, get that piece of geometry back on. And let's paint it to match. There we go. Okay, so we're back to my base simple massing object. And now we have levels established, so we should be ready to run our energy simulation. So again, I'm going to click the 19.1 energy cost button and generate insight. So this will take a few minutes. Essentially, this is calculated in the cloud, and it's going to go through a process where obviously it's converting the geometry to run the simulation. And as soon as that simulation is done, it will send me a note back, so I can begin observing what the results are on that energy simulation. Okay, so the energy analysis is complete, and at this point we can begin looking at some of the basic observations. So we'll go down to View Insight, and that's going to open up the specific energy analysis for this project. So we can see a little bit right here in terms of this 3D view, the assumptions that it's made. And again, these are not data. This isn't information, especially at this point where I'm just doing massing. This isn't information when I would say, well, this is exactly how the building is going to perform. There's a lot of variables that need to go into this. This is an idea of working through information and data early on in the design process. So as I begin to change, let's say, the overall massing shape, or as I begin to modify where exposure or glazing is across surfaces, I can begin to see immediate feedback in terms of how that's going to modify the performance, which is going to help me understand my overall design thinking. If I was on a less urban site, a more suburban site, I would also begin to do some simple things like change the orientation of the building and see the overall impact that might have in terms of energy use. As we have more defined properties of the project, we can continue to update the simulation to eventually get some very accurate data in terms of how it will perform. So right now, think of these as generic numbers and look at larger trends. This modification makes this kind of adjustment in terms of how the building is going to perform. So a couple of things that we can begin to do with this insight. Let's go ahead and flip building orientation, and we can get an idea of changing the building orientation is going to have this kind of impact overall based on the size and shape of the building in terms of what's going to happen. I know I'm locked in really on this site though, so I don't really have a lot of opportunities to modify building orientation in terms of this urban site. The window to wall ratio, southern walls. I've got a nice sort of southern edge on there, so I know I probably do want a lot of glass on that. But again, I can see some definite variables, some definite opportunities to change the way things are going to work and the way things are going to perform. So perhaps on this, I might narrow this down in terms of the definition and say no more than 50% of that southern wall is going to be exposed. So I can kind of tighten that in and then close that. Window shade. So if I flip that over, I know that if I have some shading devices on this, I have some definite energy savings. So let's go ahead and assume that I might do some window shades. And then the glass type on the south as well. I know if I do a triple OE, I have this pretty major drop in terms of cost. So obviously triple OE glass is going to be a much more expensive construction option, but I can begin to use that number right here to work both with the initial cost versus cost savings for this area. So let's go ahead and close that. So again, you can kind of repeat this process throughout. I know, let's look at window wall ratio on the northern wall. Well, we know we don't have any glass at all. We're actually sharing a facade there. So we can close that. And let's look at additional options down at the bottom. Wall construction. This is going to give me the type of wall system and wall insulation. Same with roof construction, uninsulated versus structurally insulated panels. Infiltration in terms of what standard and specifications we're meeting, so on and so forth. One of the other big ones to notice as well, looking both at HVAC system and operating schedule, you'll notice if it's a 24/7 building versus a occupancy load 12 hours a day, 5 days a week, you'll notice that people really are one of the biggest costs per square foot in terms of energy. So going through these, explore these panels and sort of begin to figure out which things are going to have the major impact, and also which items are going to have an impact and immediately influence your design thinking on a project, as this is really important data to observe early on in your design thinking process.